Hello, students. All of you, welcome at Physics Point. So now, students just wait for few seconds, few minutes, so that each and everyone wait student for few minutes, so that more student can connect and more student can get benefit. So, student in today class, no, what I'll discuss very interesting and very easy. Student in today class, I'll discuss it's literally super important and highly easy beta. I can say in all chapters, whatever that I mean, morning shift, evening shift, or students, you can say like any competitive examinations, there is one question compulsory, at least one question, my dear. So today I'll start your class. Just beta, just wait 5 minutes at least. Student, just wait 5 minutes. After 5 minutes, beta, I'll start the class. 12:45 onwards. Sprint 12:45 onwards, I'll start the class. Right. Okay. Jai Sri Ram student. Jai Sri Ram. Just wait a student for few minutes. Okay. Jai Sri Ram student. Student just wait for few minutes. Okay. Fine. Now student, time already gone 2 minutes. Bit hardly, I can say 12:45. Then I'll start the class as usual. So, what's the topic which I'm going to start? That is, students, I can see gravitation. So, student, gravitation literally it's a highly important and highly easy. You can also say like that. Highly easy. You can also say like that. And at physics point, physics always feel easy only, right? Okay, Jai Sri Ram student. So now time all I can say already gone. So student, I have to start gravitation. What might here? I have to start what I can say gravitation. So before going to start gravitation, student, just we'll go through basic point, my dear. Right. So first, student, I'll discuss. basic point of gravitation, right? So this is into the class. I'll discuss this is gravitation. Student, I'll discuss this is what gravitation. So in gravitation, student, what is the basically things which I can tell over here? Student, basically in this gravitation, there are many topics like gravitational force. After that, student, I can say gravitational field, right? Orbita, I can say like gravitational potential energy, gravitational potential. Uh, this is students. After that, I can see these all are a part of G1. That means I can see in gravitational field, I have to discuss types of sphere, like hollow sphere, solid sphere. What is the gravitational field inside the sphere? What is the gravitational field outside the sphere? These all things, students, I can say I have to use, right? So, means I'll discuss better, slowly, all the points. So Vitaji, I can say for this condition in gravitation, student, gravitation. First, we have to understand what is the gravitation. What is the gravitation? So, it, a gravitation force is one of the fundamental force of nature. What is student? Uh, Gravitational force. Okay, very good, very good. Happy to student. Happy to see my dear. Happy to see your score. Yes. Uh, Very good student. So, student, I can see what is the gravitation? As I said, my dear, gravitational force is one of the fundamental force of nature, right here. Okay. Now I can say I'll discuss gravitational force. No, beta, it's a lengthy topic. It's a, I can say big topic. Okay. Students, I'll tell analysis of paper beta once I'll get na exact paper of NTA. Dear, once I'll get exact paper of NTA from NTA side, the students I'll tell exact thing for you. Student, then I'll tell you exact thing, beta, what is the percentage according to your score, right? So, beta, here, student gravitation. Gravitation, my dear, I'll discuss in two ways. Beta, gravitation, I'll discuss, my dear. I can say in two ways. I can say in two part, you can say, not two ways, beta, right? Gravitation student, I'll discuss in two part. That is, students, it's a lengthy, my dear. Due to this, myself categorized in two part. What is students? This is, students, I can say G1. This is what, my dear? G1. And another one, beta, I can say this is what G2. Student, gravitation is a lengthy chapter. Lengthy, I mean to say कि like there is a point to discuss individually. You can easily enjoy the class, easily enjoy the I can say subject. So gravitation is divided into two parts, G1 and G2. What my dear? G1 and G2, right? So students, in G1, what I'll discuss. Students in G1, beta, I'll discuss first in G1 beta G. That is, I can say gravitational force. Students in G1, I'll discuss gravitational force. Under G1 students, I'll discuss gravitational field. What, my dear? Gravitational field. Third student, I'll discuss in, I can say G1 only. That is gravitational potential energy. What student? Gravitational potential energy beta. Okay. Then beta, I can say in fourth. I'll discuss gravitational potential. What, my dear? Gravitational potential. Students, I can see this is the major topic which I'll discuss in what? G1. Which I'll discuss in what? G1. Means I can see in field there are many things I'll discuss like gravitational field for hollow sphere, gravitational field for solid sphere, gravitational field for rod, right, beta? Variety of the things. Now, beta, I can say in G2, what I'll discuss majorly and what is the weightage of the G2. I can say between G2. First, I'll discuss. I can say concept on acceleration. There are four cases. Students in G2, I'll discuss. There are four cases like gravitational acceleration due to gravity on Earth surface, case one. Then with respect to height, with respect to depth. Then beta, if Earth is rotating, then what is the value of G? Right. Hello, student. Right. So this is beta. I can say basics. I can say what types of. This is what my dear. I can say beta types of acceleration which I'll discuss. Jai Shri Ram beta. Now, students, I'll discuss next point in this. I can say this is a more and most important, my dear. You can write. This is what escape velocity. What beta G? I'll discuss escape velocity. Then we have the concept of energy and satellite. Concept on energy and satellite. Concept on beta what? Energy and satellite. Students, you have a doubt. It's very good. Beta, if once I'll finish the class, then you have to send me doubt here only. I'll take your doubt, student. Don't worry. Stay in the live session only. Student, it's a normal class of gravitation for 11th class student. Those are in 11th class are preparing for JEE and NEET as well. You can watch the lecture at anywhere from entire India. Now, beta, what is next concept on? I can see energy and satellite. Energy and very good, beta, very good. Percentile student, I'll tell one. I can say there is one boy also asked, beta percentile. When I'll get students like no, beta, I'm from Bangalore. Beta, I can say once I'll get NTA paper, beta, then I'll tell you what is the students like mm, uh, percentage percentile according to score. Beta, then I'll discuss the concept of energy and satellite. Beta, what is the major things you will get maximum questions in JEE? From what, beta? This is Kepler's law. This is what, my dear? Kepler's law, right? So these are the basic introduction, student. Now I'm going to start your class as usual because many one already joined. Okay, if you should just stay connected at phase one, beta. Students, stay connected at phase one. You will, I can see forever, you will enjoy with concept and with confidence as well. So now, students, I'm going to start, my dear. Now I'm going to start, my dear. This is what I can say. This is what, my dear, G1. Gravitation part one, I'll discuss, beta. In this, students, I'll discuss. In this, students, I'll discuss that is beta A, Newton's law of gravitation. Beta here I'll discuss, student, here I'll discuss Newton's, student, here I'll discuss Newton's law. Oh, Newton's law of gravitation. You got delay, Srians, Newton's law of gravitation. Okay, beta, this is a fundamental law of gravitation. This is what, beta? Fundamental law of gravitation. Okay, fine, Bachaji. I can say, what is the Newton's law of gravitation, my dear? Students, let us suppose, here I'm considering there are 2 point mass body. What is student? There are 2 point mass body. So, students, I can say for this condition, this is the body. Betaji, I'm considering this is M1. I'm watching it. Okay, very good, Shans. Now, students, I can say that's why I'm now I can say topic started from now only. Students, a concept started from now only, my dear. Now, students, I can see this is M1 and this is what? M2, right? There are two beta 2 point mass, right? Beta, this is the force. This is the force in the nature. This is the force in the nature, my dear, which is always attractive. Gravitational force, that is, I can say, first point which you can keep in your mind. Gravitational force always attractive in nature, right? So, student, what you can say, this is the body M1. M1 is what? Experiencing force in what? Right directions due to, you can write with that. M1 force on 1 due to 2. Students, M1 it can experience a force or experiencing force on during right directions due to 2. Similarly, you can say, student, force on 2 due to 1. Force on 2 due to 1. Okay, now students, what I can say, my dear, for this condition, this is a kind of things you can connect yourself from what? Newton's third law. Newton's third law. There are two body. This is the first condition, beta G, for Newton's third law, or you can say action reaction pair. There are two bodies satisfying. Direction must, no matter what is the point, you can take in your mind. I can say for Newton's law, I can say beta action reaction pair. That is Newton's third law. Student, if there are two bodies satisfying, there are two bodies, magnitude of force same. That is this also satisfying beta. No, what is the major point to call Newton's law of gravitation? What is the major point, beta, to call Newton's law of gravitation, or you can say action reaction pair? What is student? What I said? What is the point which you can take for consideration in students' action action reaction pair? Beta, this is point number one. Both body, I can say, force, magnitude of force, student, magnitude of force, same, right? This is first point. Second point, beta, what you can tell, my dear? This is direction must should be opposite. Student, direction must should be opposite. These 2 points satisfying beta G. Third point, beta, always not satisfying everywhere. What is my third point, beta? Students, I can say for this condition in point third beta, nature of force must same, right? But if there are 3 points, then you can say, I can say this is what belongs to action reaction pair, beta. No, just I'm just giving you one more example to understand what is action reaction pair. Now, bacha, just example I'm giving you how can you say action reaction pair here. Beta, you can take this is the body, which is you can see body lying on a horizontal plane. Now, students, here you can see this is M is the mass of the body. Basically, I can see placed on a ground level of Earth surface. Beta, due to this, you can say mg force acting in downward direction. Right, my dear? I hope all of you remember normal force always acting in perpendicular direction. Since here, magnitude of force, you can write system is in remains equilibrium. So students, the first point is satisfying. First point satisfying. Students, second point also satisfying here. Direction must should be same. Yes, this is satisfying. But beta G, third point is not applicable. Third point is not applicable. Why, dear? You can say, Bacha Ji, beta G, normal is what? What I said. What is the major point to call anything belongs to action reaction pair? Magnitude of force same, beta direction must should be opposite. Nature of force must should be same, right? Beta, what is nature of force? Beta, normal force is what, my dear? You can say this is what? Electromagnetic. Beta, this is what? Beta, what, my dear? Electro, it as a electromagnetic force. What it as the electromagnetic force. Students, as I see here, beta, date. Once I'll get open the paper, then I'll tell the students. Now, mg is what, beta z? Don't disturb here during class, beta. It's a normal class. Mg student, I can say this is what, my dear? Mg is what, my dear? This is gravitational. This is beta G gravitational force, right? So these two are different force. So students, you can't say this is what action reaction pair. So now I hope you understand what is action reaction pair, beta. Now students, I'm going to tell you what is the mathematics behind can see Newton's law of gravitation. Newton's law, beta, what I can say, gravitation. Okay. Students, I can say for this consideration, you can take snapshot beta. Student, you can have to take snapshot, right? I'll just move next paper. I'll discuss mathematics. I'll discuss students. I can say mathematics for Newton's law of gravitation. So here, students, this is M1 body beta. This is M1 body, students. This is what beta is M2 body. Let us suppose both are separated beta what at a distance r, center to center. R is what, center to center distance, right beta? Or you can also say this is M1 body and this is now separated to what, M2 body. Now students, this is what I'm calling R. Beta, what I can say, beta, what is the first observation? Gravitational force, either this is what? Directly proportional to product of mass, beta. First point, keep in your mind. Gravitational force, what? Directly proportional to product of mass, beta. That is the first point. What is the mean, beta? Let us suppose you can understand with the help of another example. Beta, you can say, this is what, my dear? 2 kilograms. This is 4 kilograms. Just you can take this understanding. There is no any such thing, beta. This is a 2 kilogram. This is the 4 kilogram. This what is the force? You can see 2 force are 8, right? Now, students, I'm keeping remains constant in another example. This is remains 2 kilogram. This is what beta the 8 kilogram. Now, what's the force? You can see 2 8 is 16. So, student, what does it mean? These two example here, student. Either you are increasing or decreasing these two masses. So force will increase or decrease in multiple. Student- Students, again I'm repeating. What is the meaning of force directly proportional to M1, M2? Either you are increasing any of the body, then force will increase in multiple. Student I, or you can say if you are decreasing the area of the body, so force will what, decreasing multiple. That is the meaning of what, force directly proportional to M1, M2. Now students, either if we will increase R, then what beta you can say, force will decrease, interaction force will decrease between the body, right? Student, if you will what, decrease R, then interaction force what, increase between the body beta. So here you can write for mathematical, this is what, force directly proportional, or you can say the inversely proportional to what, 1 upon r square. 1 upon r square. Student, if you are getting a student, that is, you can say, if anywhere, for any quantity proportional to something, then student, you have to just remove and use what, some suitable constant, my dear. So here you can say, beta, force is what, minus g m1 m2 by r square, minus g m1 m2 by r square. Student, what is the meaning of minus here? Students, minus is just I can say mentioning what is the nature of force. So, what is the gravitational force? Gravitational force always attractive in nature. What, my dear? Gravitational force always attractive in nature, my dear. Okay, that's all. So, beta, here, what is the point which you can keep in your mind? That is, forever we'll use formula as a magnitude only. F is what? G m1 m2 by r square. Minus just take in consideration for just representing direction, or you can say what? Representing gravitational force always attractive in nature. So here, one point you can ask, one questions you can understand. What Bachaji? What is G? G students, you can say gravitational. What Peter? G is what? Gravitational student constant. Student G value already defined by method, but not required. I'm telling you straightforward. G student, you can take a 6.67, 6.67 into beta 10 to the power minus 11 Newton meter square per beta G kg square. Okay, fine. Next student, here one thing you can just keep in your mind. What is the SI unit of G? So what is student? You can say Newton meter square per beta G kg square. If you are not able to cope up this one, then I'm giving you one trick. Beta, whatever thing, this is G. Whatever thing you wanted, then you have to remove from crowd. That's all. That's all. If you don't know how it came, Newton meter square kg square, then student G you can just remove and write beta straightforward. So beta just you can just do cross multiply. F into R square upon beta M1 M2 is equals to what G only. What is the SI unit of force? Which is equals to Newton. R is what beta? You can say this is the meter. M1 M2 beta. Both are what? You can say mass. Both are what beta? You can say mass. Right, my dear? Okay. So I hope you got the point. Student, one more point you can also connect over here because what I'm discussing because these all are highly important. What they can ask, don't leave any basics point. Nowadays, they are asking more basics points only, beta. So that's why I'm just doing each and everything in front of you only, and you can easily understand. Now, Bachaji, what I can say, Bacha, this is dimensional formula. What is student? Dimensional, dimensional formula of G. Beta, you can write directly. What is this dimensions of Newton? Tell Bachaji. This is, tell beta. M1, L1, T minus 2. Force is equals to mn beta. I can write simply here. Okay. Beta, there is what? Meter square. So you can also write this is L square. Beta, mass, what we can say? SI unit of mass. This is what? You can say with Chaji M square. Now, yeah, just you can see this is cancelling each other. So finally, students, you can write gravitational dimensions of G, dimensional formula of G beta, m to the power minus 1 by m to the power minus 1 beta. This is L to the power 3, and this is what? T to the power beta G minus 2. This is, student, I can say, student, you have to take snapshot. Take beta this snapshot here. Okay, beta. So this is what I can say dimension formula of G. Now, beta, there are basic points which I wanted to discuss. What is today? Gravitational force points about students, points about my dear, point about my dear gravitational force. Okay, beta, this is the first point. My dear, this is the first point. Gravitational force, beta. Gravitational force, beta, what you can say? Always attractive in nature. Beta, this is first point here. Gravitational force, beta. Gravitational force. Student, here I'm writing everything. In classroom, I'm not writing. It's a live class, so I have to write each and everything. Student, gravitational. Also, you have to make a notes with us, Shreyans, with me only. gravitational force, what beta see? Always attractive in nature beta. First point. Beta see gravitational force independent independent on student medium. Gravitational force beta, what you can say? Independent on medium. Right, beta. I can say after this, beta, also you can connect with a few points about gravitational force. About gravitational force. Right, bacha Bati? So, this is the point. I majorly you can just keep in your mind these 2 points. Then, bacha, gravitational force belongs to quantity vector. Belongs to quantity vector. Beta, what is the SI unit of gravitational force, beta? As usual, you can see any kinds of force here. SI unit is what? This is, you can say, beta, the Newton. You can tell, my dear, this is what remains in Newton. This is the basic point, beta, which you can keep in your mind for gravitational force. For beta, what I can say, gravitational force. Okay, beta, this is one more point, beta. It is a conservative force. What, my dear? It is a conservative force. What, my dear? It is a conservative force. You know, what is the conservative force? Which is independent on path. Which is independent on path. Beta, it can provide radial acceleration. No, beta, in circular motion, we have a two acceleration. Students, in circular motion, we have a two acceleration. Right, beta? So, gravitational force, it can, it can provide, it can provide what, beta? Radial acceleration. This is what students, you can say radial acceleration. This is what, beta? You can understand, beta, ji, how? No, let us suppose you can say this is the sun. This is Earth. Right, my dear? You know, Earth is what? Revolving around the sun. Earth is what, beta? Revolving around the sun. So here, students, you can say FG. So this FG is what? Playing a role of, FG is what, beta? Playing a role of what? Tell, beta? Radial force. Right, beta? Or you can say radial acceleration. Now, students, it is it is communicated through a particle called as gravitation. It, know these force communicated to each other. This force communicated through a particle called what? Gravitation. Called beta what you can say? Gravitation. Okay. Now beta, these are the basic point about gravitational force, my dear. Okay, attraction. Correct, correct. Very good, beta. Very good, beta. Very good. These kind of things you can write in chat box here. Unnecessary. Okay, very good. Very good, beta. Arab Sharma. Very good, my dear. Okay. Now, bacha, happy to see. Now, bacha, I can say, very good, Jitkira. Very good. Thank you for your response. Now, bacha, this is the which I discussed, beta. I can say gravitational force basics. You know, this is down to earth explanation which I gave you for gravitational force. Now, since time came, I have to just discuss. I wanted to discuss student variety of numerical. What beta the variety of numerical? Okay, beta one more thing here I forgot. Beta I can say gravitational force is a central force. What beta? This is gravitational student. Gravitational force is a what, my dear? Central force. This is a central force, beta. Okay, I can say action reaction. Okay, Arav, already I said, beta. Maybe it has one newly, right, beta? I said, beta. I discussed all the point here only, and also I wrote, beta, what is the action reaction pair? I explained everything which I explained to student in the classroom as well, my dear. Very good. Thank you, Vita, for your response here. Literally, I'm feeling proud, Vita. Okay, sir, your teaching style is okay. God bless you, student. God bless you, student. God bless you, student. Very good. Thank you for your, I can see, positive response. Now, students, have a look next. Beta, you can draw the graph as well. So, beta, what is formula which I gave you, bacha? F is equals to what, my dear? G M1 M2 by R square. Arabita, can you tell bacha? I want you to draw the graph. Student Arab, I want you to draw the graph force versus R square. Students, can you tell me what is the nature of graph beta? Like a straight line, hyperbola, parabola, circle. Anyone from all of you? Anyone from all of you? Can you tell a student what is the nature of graph? Okay, I'm telling you. I'm telling you, beta. Anywhere, beta. Anywhere. This thing already I beta said in previous video. Anywhere, student, anywhere, if you are getting hyperbola, super, very good, beta. Now, rectangular hyperbola, beta ji. If you are getting, listen carefully, everyone. If just beta do cross multiply, so you can write beta ji. Force, force into very good Jitkira. Now, force into R square. What beta? You can say G M1 M2. Beta, G also constant as you know everyone. Mass beta is also constant as you know everyone. Very good, my dear Arab. Arab beta, I love you so much, bacha. This is beta GM1 and 2. Entire is constant. So, student, this thing I said in the classroom. That's why Arab is reacting in chat box. Very good, Arab beta. If a product of two variables, students, if a product of two variable, you are getting constant. Then, beta, what we can say? What is the nature of graph here? This is beta Z rectangular hyperbola. This is what beta? Hyperbola. Right, Bacha ji? So this is the things here. You can draw beta graph. I'm discussing every point here so that you can enjoy the class. Because I'll not leave any weak point. So this is the graph beta, force versus R square, force versus R square, my dear. Now, yeah, this is when now time theory finished for Newton's law of gravitation. I'll do students only numerical. Everyone make notes with me and beta just respond me numerical as well. So, student, this is the basic questions and asked by J multiple times. So, what's the question, beta? Have a look. I can see all of you also excited, sir. Last 30 minutes, just sir. I can say learning only theory. So now time came beta, all of you can just do numerical beta. So what, my dear? Here I'm considering an equilateral triangle. Student, here I'm considering an equilateral triangle. Beta, now this is students, I'm considering everywhere identical mass, which is equals to m. Students, everywhere I'm considering identical mass, which is equals to m beta. Okay, fine. Students, an equilateral triangle, so I'm considering A is what? Side of a triangle. A is what? Side of a triangle. Beta, you need to find student, find F net. I'm giving you freedom. Find F net at any corner. At any corner. Find F net beta. What? F net at any corner. Okay. I'm giving you beta. Few seconds you can do. You can do beta. Then I'll give you the questions. Then I'll solve a separately. Find F net. Find F net. It's a live class for entire India student who want to learn physics bottom to earth. Right. Here I'll discuss each and every point beta ji. Find F net at any corner. Find F net at any corner. Find F net at any corner. Now, Bachaji, now I'm going to Bacha, I'm going to start explanation Bacha party. Yes, beta. Correct, Bacha. Root 3f. Okay, very good. And what is your beta? Very good, yeah. Ara Bacha. Very good to see you, Bacha, your response here. Okay. Beta, Ara Bacha. What's my solution, my dear? What's my solution, beta? Okay. Now, beta, as I said in the class, Gravitational force beta always attractive in nature. Gravitational force beta what? Always attractive in nature, my dear. So you can say this is mass m, this is mass m, and this is mass m. Students, here I'm considering. Sir, I told R. Okay, fine, fine. Now, which this is you can tell you. Student, I'm considering point one. This is point two. This is what, my dear? Point three only. Okay, one, two, and three. As we know, everyone, gravitational force only attractive in nature. So students, here you can write this is force on 1 due to 2, right? So student, here you also write what is the force on 1 due to 2. So beta formula you can apply force on 1 due to 2. This is G m1 m2 by r square. So beta, r is equals to a beta. You know, r is equals to a beta z, and m1 is equals to m2. M1 is equals to m2 beta. So finally, you can write beta z. This is F force on 1 due to 2. This is gm square upon beta z a square. Right, my dear? Next here, students, here you can write. I'm considering this point. You can take anywhere. Answer will be same only beta. This is students force on 1 due to 3. So here beta you can write force on 1 due to 3. This is what? Same formula can apply beta. G m1 m2 by r square. So what is student? You can say g m square by a square. Okay. Now students, beta z, uh, no, force belongs to quantity vector. I hope all of you know. Otherwise, I'm telling you. Any kinds of force always belongs to quantity vector. So student, here you can't say simply add. No, you can apply vector summation to get answer F net of these two forces. So student, listen carefully here. This is a part of gravitation. Now onwards, I'll teach you only what beta. I can say, bacha ji, gm square by r square. Correct, Jeet Kira. Now, bacha. So this is the force beta. Force on 1 due to 2, force on 1 due to 2 beta g, right? Next beta, this is the force. You can say 1 due to 3. Beta, I hope all of you know. Angle, every angle in what? An equilateral triangle, which is equals to 60 degree. Which is equals to 60 degree beta. So now you can apply simply here. This is vector summations to add these two formula beta g. What you can say beta? This is f. You can start apply to it for f net 60 degree. Correct, student. Good beta g. So f net student, f net you can apply square root of force beta f1 f2. This I'm calling f only here. F1 f2 magnitude beta g. Say F1, F2, F1, 1, 3 students. Here I'm calling M only beta. So what you can say A square means F square, A square plus B square plus beta Z 2AB cos of 60 degree, my dear. Right. So students, you can write over here F net is equals to what beta? This is f square plus f square plus beta g 2f square and cos 60 1 by 2. 2 to cancel bacha. 2 to cancel bacha. Now you can say f square plus f square plus f square. How much beta g? This is what you can say root 3f. F net student already Arab answered this question. Okay, yes, God. Very good, Arabita. Literally, you are doing very good here in live session. Root 3 beta. F net is what beta? Root 3f. And f is what beta? Already be found. G m square by a square. So answer you can write beta for this question. This is what beta? This is root 3 G m square by a square. Student, this condition, same questions you will get in the electrostatics as well. Student, same question you will get in electrostatics as well, beta. Okay. Fine, because here I what I have taken, this is mass. In electrostatics, you will get everywhere that is charge. Answer will be same only. Root 3 cm square by a square. Okay, now let's have a look next questions here. Next question, beta. So this is students. Shreyans, I'm not getting any reply from your side. Are you there? Shreyans? Now beta, find F net. Student, find F net at any corner of square. Find beta F net at any corner of the square. Figures one, my dear. Figures one, my dear. Now beta, this is the body. Square students, I'm considering side of a square A only. Student, a side of a square A only. Right. And oh no, for a square of side it remains same everywhere. Student M1, M2 for this less calculation, I'm considering identical. There are four mass which is placed on the, I can say, corner of the square, my dear. So what question we have to find F net? Okay, students have a look at everyone. So student, how can we do? Beta see, now beta I can say, let's just go through this here. Again, beta, I'll just take pair. This is one, two, three, and four. One, two, three, four. Right, my dear? Okay. Students who are here, again, you can see this take for consideration. This is first beta. Force on 1 due to 2. Force on 1 due to 2. Then beta Z, I can say force on 1 due to 4, force on beta 1 due to 4, right? So beta, first you have to find these forces. So beta, both are at 90 degrees. Both are beta, what you can say 90 degree. Both forces 90 degrees, student. Student, here I'll use straightforward formula here. I'll not waste much time. Beta, this is force on 1 due to 2. Students, as you know, force on 1 due to 2 and beta magnitude of force. I'm just talking. Force on beta, this is 1 due to 4, which is remains same beta. What, my dear? Gm square by a square. So this is beta. I'll see. Student, this is I'm calling F only. So first student, you have to find these two forces. So what beta? This is also F, my dear, and this is also F. Okay, yes, Arabita, very good, Arabita. Very happy to see your confidence, Vita, in live session. Now, students, you can say if we have a two vectors quantity and both are beta what? Beta both are what? You can say 90 degree. Then beta simply can apply at the formula. So getting F net, F net due to this 1, 2 and 1, 4, not for entire system. What I asked F net at any corner of the square. So here students, I'll write F net due to 1, 2 and 1, 4. F net beta due to 1, again, just listen carefully beta. F net due to 1, 2 and 1, 4. Beta, how much? This is root 2, root 2 f beta, right? This is, I got F net due to this pair only, but you can say beta, still I have one pair. This is, you can say 1, and this is, you can say 4. Beta, this is, you can say, side of the square is what? A. By Pythagoras theorem, you will get, this is what, my dear? Root 2a. What you will get, my dear? Root of 2a. Simple, bacha. This we can apply the formula for of f1 due to 4. This is what, my dear? G. Here also m beta g. Here also m beta. So this is gm square by, student, you can write root 2a beta g whole square. So force on 1 due to 4, you will get, my dear, gm square by 2a square. We wish to find f net at any corner for entire beta. Ah, yes, wait. But I know someone is also requested beta for, I can say, classes. Very good, Jeet ki raha, beta. Very good, Jeet ki raha, beta. Okay, beta, I'll do all the question, beta, in the sequence here, in the sequence, beta. Don't be hurry, beta. So beta, we used to find f net at any corner of the entire square beta. Okay, I can see beta f net in life and yeah, students are coming and going beta. Then how can I say beta like say responding only loving air who is responding more in the classroom, maintaining discipline, decorum of the class. That is a beta favorite, my dear. F net beta for entire system beta. What you can write? This is F net beta. Root 2 F plus beta. This is G M square by 2A square. F beta remains same here. So you can take beta F is common. So what answer? Root 2 plus 1 by 2 beta. So your answer is supposed to write finally. This is what, my dear? Gm squared by a square beta root 2 plus 1 by 2. So this is student, we got questions from here only, right? Okay, fine beta. Have a look here. Next question, take snapshot beta. Stay in the meeting here regularly, right? Visit physics point. I can say beta. As per time to time here, right? You will get beta everything in your life. Now, bacha, have a look next questions here. That is a very common beta. I can say problem based on series. I can put the heading beta. This is what, my dear? One more question I want you to do. Right? But let us suppose this is hexagon. This is what, my dear? This is the hexagon. Right? Beta, everywhere I'm placing identical mass. Side of hexagon, this is beta, you can tell this is A beta only. This this is M everywhere. Beta, center of hexagon here. I'm placing this is M naught. You need to find beta F net. It's homework questions. You students, you can respond your homework at telegram of physics point, right? I'll say very soon. I'll say very soon beta. I can say F net beta C F net at center point O. F net at beta center point O. Right, Bachaji? Okay. This is the homework questions. You can do at home here. Now, students, have a look. Problem based on series. What beta? This is problem based problem based on series. Okay, this is first question here. Find F net mass placed at beta origin. What question beta? Find F net mass placed at beta. What I can say origin. Are your answer correct beta ji? You answer for this question beta for hexagon na? Correct beta. Your answer correct. But still, I wanted solution. You can revert me. I can say channel of Regis Point like Telegram. I'll tell you very soon. For meanwhile beta, you can also save your answer here. This is B. Dot Sharma on mail beta. B. Dot Sharma. This is 9219 student at the rate of gmail.com. You can you also revert your answer over here beta. Now FNet beta for series questions here. So now students, I'm placing over here. This is origin point. This is O. Beta here masses. I'm taking here. This is 1 kilogram. This is 1 meter beta. This is remains 1 kilogram. Beta, this is 2 meter bacha ji. This is 8 kilogram. Right, beta? Okay. Then beta, this is 3 meter beta. This is, you can say, 27 kilogram. Now, students, this is 10 meter. Beta, this is, I'm considering 1000 kilogram. Beta, what I said? I said you need to find F net, mass placed at origin. Look, students, questions here. Uh, So beta, it's very easy. Literally, beta, it's very easy. Just listen carefully. If you will understand this one, then students, I can say, beta, just do next questions, right? Understand beta this one? Then you can do coming two questions here because these three questions are interlinked to each other. Beta, just I'll go slowly here one time. Beta, I know gravitational force always applicable for what beta? Pair of mass. So this is 1 kilogram, this is 1 kilogram beta. So you can take first pair beta. This is 1 kilogram, my dear. This is 1 kilo. No, beta, I said, Arab, this question solution you can send me on mail. Meanwhile, I don't know, beta, forget my Telegram channel ID, right? Beta, meanwhile, you can beta just send me solution of these questions. b.sarma9219 at the rate of gmail.com, beta. Now, have a look here, beta. So, first, beta, you can just be concentrate here, beta, Arab. 1 kilogram, 1 kilogram. You can take beta first pair. So now beta, this is what the distance is here. This is beta 1 meter. So we can find beta, this is F1, which is nothing but it's a G only. G M1 M2 by R square beta. G M1 M2 by beta R square. F1 is G beta. Now take beta consideration always at origin. Next pair beta, you can say this is 1 kilogram. And this is what beta is 8 kilogram. So what's the force? Again, beta apply same thing here. Student for F2, this is what? G M1 M2 by R square. So what beta? G into 1 into 8 upon 4 beta. So you can see that this is what? Basically 2G. Next student you can take here 1 and 27. 1 kilogram and my dear 27 kilogram. Right. And so beta, this is you can say F3 beta. So this is G M1 beta 1, M2 student, this is 27. Upon beta is what you can say 3 3 is a 9. Now, S R beta, beat my solution beta, I'll beta, I'll tell you students, 9 3 the 27. So this is what 3G beta. Up to what you can see beta. This will go further here. Then you will get F3, F4, F5, X6, X7, F9, F7, F8, F9, and F10 beta. Right? Okay, SR beta. Yes, beta. Maybe you're maybe correct, beta. Yes, correct, beta. Arab. Just watch. Wait and watch my solution, beta. So F net students, you can write this is F1 plus F2 plus F3 beta. Let us suppose I'm calling for Fn, n time beta, not 10. Then you can see beta, this is G plus beta G, 2G plus beta G, this is 3G, and beta what? You can say n times of G. Then bacha, you can say, take common beta. You can tell, sir, this is the basically series. This is what series beta. Anyone tell me what is formula of this series? What is the formula of this series beta? Anyone? This is series here. 1, 2, 3, series and so on beta. So this is, I can see series formula n into n plus 1 by 2 into g beta. N here, what you can replace? Yes beta. Hmm. Correct, Arab beta. N is beta what? 10 you can replace here because that is maximum length is 10 beta. Maximum I have taken 10 beta. 10 into 10 plus 1 by 2 into g beta. No, it's 55 g beta. 11 by 2. Beta, it's 55G coming, beta. Arab, it's a 55G. It's a 55G, beta. Yes, beta. Yes, Zikra, beta. So Fnet, beta, what will you, if you supposed to write here? Arab, Fnet student, it's a 55G, bacha ji. Okay, hey, Arab. Okay, Arab, beta. No, beta. This is formula here. Beta, 1, 2, 3. Then beta, I can replace here. N into n plus 1 by 2, bacha party. Okay. I hope you understand everyone here. Bacha, just please be like and here. I like to say everyone. Hit this channel. Like video, bacha. Share with your friends and family student. Now, student, have a look. Next questions here. Students, have a look. This is the next question, beta. Questions remain same. Questions remain same, beta. Fine. So that maximum student can get benefit from physics 1 beta G. Find F net. Find F net. What beta? You can say again beta same thing. Mass placed at origin. What beta? Mass placed at origin, my dear. Okay. So beta, this is a supported diagram here for this question, beta. This is students, I can say 1 kilogram. This is remains beta 1 meter. This is again beta is 1 kilogram. This is a 2 meter beta. This is a 16 kilogram. This is the beta is 3 meter. This is 81 kilogram, my dear. This is 10 meter beta. This is 10,000 kilograms. Questions remain same here. Questions remain same, student. Right? You need to find what is F net if mass placed at origin for entire system. So, student, do you want try or I have to do? Do you want try or I have to do? Anyone from all of you? Okay, I'm doing beta. What's my solution here? Beta G for this condition again use beta same pairing here 1 and 1 beta. This is students, you can say F1 student 1 kilogram, my dear. This is 1 kilogram. What's the separation? This is 1 meter, right, beta? So you can say formula can apply C m1 m2 by r square beta. So this is what G only. Students, you can write F2 also. For F2 beta, this is 1 kilogram. This is my dear 16 kilogram. What's the separation beta? 2 meter. So you can write F2 is equals to G 1 into 16 upon beta G 4. 4 for the 16. You can write 4G. Or beta, you can say F2 is equals to 2 to the power 2 into G. F3 beta, you can take my dear. This is 1 kilogram beta, and this is what you can say 81 kilogram. What's the separation, my dear? This is 3 meter, right, beta? Okay, so F3 you can write beta J. This is G M1 M2 by R square. So G into 1 into beta G 81 upon beta, this is 3 3 is a 9 9 beta G 9G. F3 you can write this is 9G beta or 3 square into G, right, my dear? We wish to find F net for entire system. Fnet beta what? We will define Fnet for entire system, my dear. This is what you can say. This is F1, F2, F3 beta. Up to here, you can say this is what Fn, which is just decentralized result beta. Right, my dear? This is what we can say. This is G plus beta 2 square G plus beta G 3 square G and so on beta. What you can say n square G. Beta, you can take G common, my dear. So 1 square plus 2 square, student, 3 square, and this is what? N square beta. Now, what is the series of this formula, beta? What is the series formula of this? Anyone from all of you? This is, my dear. Thank you so much, sir. Your lectures are very clear and truly inspiring. Very good, Jitkira. God bless you, beta. God bless you forever. All the very best for your life. Stay blessed. Stay blessed, beta. Now, beta, what is series formula, beta? 1 square, 2 square, 3 square, and n square, beta. N into n plus 1 into beta. This is what, my dear? 2 and plus 1 by beta is 6. By beta is 6. You can fit beta here only. So, students, I can say thank you so much, Jitira, for your valuable comment and kind word. This is a G student. You can use beta this formula directly n into n plus 1 are a very gone beta. You are not responding in these questions there. Right, Bezaji. N beta, what you can say? N is beta 10 only. So this is G beta 10 into what? You can say 11 into beta G 21. Upon beta G 6 here. So 3 sevens are beta 21 here and 3 to the 6. So you can say beta 2 fives are 10. 11 fives are 55. 55 into 7 beta. How much coming here? Whatever students, you can say 55 into 7. 55 into 7 here. Do 7 5 the 35. 35 beta 385. This is what beta you can say 385 G only. 385 G only beta. Okay, have a look next questions here. Have a look next question beta G. Okay, I can see beta those questions beta you can just use beta G for gravitational force. Beta G what I can say beta gravitational force here like series formula question beta, right? Because we did beta what's the question here? I want you to write once an infinite number of particles. Beta, what's the question? An infinite, just I'll say question. I'll just go through diagram beta. There are beta, I can see infinite number of particles. Go through diagram beta. There are infinite number of particles. One particle beta placed at origin. You can see this is what beta g? 1 meter. This is mass remains same. Beta g, this is 2 meter beta. This is mass remains same. Beta g 4 meter. Mass remains same. Beta you can take care up to what? Infinite. Beta up to what? Infinite. Find Fnet student. Find the magnitude of resultant of gravitational force on M kept at origin. As I said here, said everywhere, same questions. Find F net mass placed at what beta? Mass beta g placed at origin. Simple bacha. See beta, you can just go through this. Logic beta. This is first pair M and M beta. Then next pair M and M bacha. Then next pair M and M bacha party. So I'll go here slowly so that you can understand bacha ji. Sir, still when you live. Beta, I can see today I'll finish a gravitational course beta. I have a target because no, it's very rarely I'll be free. Today is Sunday beta, I'm free. So student, today I'll finish entire portion of gravitational force. Today I'll discuss only gravitational force. Tomorrow I'll discuss field. Slowly, slowly, beta, I'll come on live here because India wants, right? India wants beta. So I'll help each and everyone here. So beta, this is first pair beta. I can take this is M. This is M. Hara, I'm not getting response from your side here. These all questions, bacha. This is what beta? 1 meter. So you can write beta. F is nothing here. This is G into M square. F beta, you can say F2 here. I'll take this M and this M beta G. This M and beta G, this M here. Sir, can I go to tuition and come? Yes, sir. You can go beta. You can go beta. Now, beta, this is what? 2M beta. So F1 beta, this is F2. What beta you can say? This is GM square. By beta G, this is 4. 2 square beta G. Next student, you can take this is M beta. This is remains M only, and but this is 4M beta G. This is what 4M beta. You can write this is F3 beta. G M square by 16 beta G. G. I want to stay, but my parents are getting angry. Okay, yes, but I can do according to your parents' convenience. So you can do according to your parents' convenience, which respect your parent beta. It's highly required. Now, students, Fnet. Fnet student, what you can write? This is F1 plus F2 plus F3. Students, F1 plus F2 plus F3 and so on beta G. What beta F1? G M square beta. I can see this is GM square by 4 plus beta GM square by 16 and so on, bacha. Okay, okay, bacha. Okay, bacha. God bless you, bacha. Stay happy. Now, student, I'll take common beta, gm square. Student, I'll take common bacha. This is gm square into what beta? 1 plus 1 by 4 plus 1 by 6. But I know, yeah, it's a GP series, infinite of GP series. What, my dear? This is infinite of GP series. So, you can use straightforward answer, bacha. Result only. This is GM square. Beta, what is sum of infinite series here? I can say this is beta A upon 1 minus R. Beta, this is the formula of what? Sum of infinite of GP series. Where is I can say R. R is equals to what beta? It's a common ratio. R, what is student? You can say this is common ratio. This is what, my dear, common ratio here. So R is what? Students, it's a B upon A. It's a B upon A. But I know this is A, this is B. Next beta, like that, you can treat. So student, I wanted to find R, ratio, beta, common ratio. So I'll take beta, this is B, this is A. Just do once beta. So R, you can say this is 1 by 4. Next, you want to verify because you know beta, common ratio remains constant forever. R is what? 1 by 4 beta. So this is remains 1 by 4. So next beta I will do this is b by a beta. Again you will get 1 by 4 only. And a is what? 1 beta. So you can write use the formula beta a upon 1 minus r. So 1 upon what beta? 1 minus 1 by 4. 1 minus 1 by 4 beta. This is what? 4 minus 1, 3. So what you will get? 3 g m square by 4 बच्चा जी. This is F-net student which you got as a result of what I can this question. But literally, beta, this which I have done highly important. It's a standard question. It's a standard question, bacha. It's a highly important. So take snapshot here. Take snapshot, beta ji. Take snapshot, everyone. Make notes, beta. I can say during class only, bacha. Now, bacha. Have a look next questions here. Have a look, beta. Next questions. Right. So these are beta questions which I have done based on series. Based on series. I can see beta in gravitational force. There are many pattern of question beta that is highly required to do in the classroom. Someone demanded good question beta. So this is a good question yeah, which I'm going to do. Find F net at point P. Friends, what's the questions? When sir, important question. Now, this is this one. I'm going to. It's literally highly and superb important, which I have done. These all questions. You can also do here. Same question, student. You can also do beta. I can see for electrostatics as well. Just replace G1 is a part of electrostatics. Students, replace mass to charge. That's all, beta. My beta. So this is what question. Find F net. Find F net at Fnet at point P due to rod. Students figure shown. Students figure shown. You know, it's a highly algos lawyer. This is a very good question, beta. Now, students, I can say this is the rod. This is the rod, beta. Supportive diagram for these questions. Now, student, here I'm placing a body which is mass is equals to m. Right. This is point beta. I'm calling P. Beta, here I'm considering a rod. This is lambda kilogram per meter. I hope all of you know what is lambda. This is what linear mass density. Lambda is what beta? Linear mass density. Lambda students you can take for what you can say a ring and rod. I'm telling you these all points already you have done in what I can say center of mass and I can say rotation as well. So this is a repeat telecast for you. Now students you can say M is what? You can take beta as the mass of rod and L is what beta? I can say length of rod. What we wish to find? We wish to find what is the force at point P due to rod. Okay. So now I'm giving you it's a standard format. Students, it's a standard format here. Right. So student have a look of solution, my dear. Student have a look of solution, my dear. Okay. Now, beta, what is the condition here which you can do? Which uh, this is what beta Z. You have to move X if you are getting anywhere rod either. Which I'm telling you, this is a concept applicable here also. Rotation also, center mass also. So don't be a spam. Listen beta carefully. Sir, please mark the important questions with star. Okay. I'll do data student. So this is a good question. Good जीत के रहा बेटा. This is student. I can see good questions here. Right. So what is if you have a rod student, then you can just move student. You have to just move x. You have to move x beta. You have to move x and take element dx beta. You have to move x. This is the I can say way to do questions. Find force on a rod due to point p beta. Beta, you have to move x and take element dx. Student, you have to move x and take element dx. So, beta, we wish to find force. So, student, here, you know, what is this value? Because now, student, you have taken element here. So, you need to find what is the elemental mass. What is the student's elemental mass? Right? Which is nothing but this is dm beta g. What you can say lambda into dx. If you, I hope you got the point. I got the point beta. Yes, beta. Point p beta. This is mass m only beta. At point p beta, this is mass only beta only. M only beta. Lambda into dx. Student, just I'm telling you this point here for those candidate who is newly don't know about beta. I can say basics of rotation and center of mass beta. Lambda beta you can write. Lambda students you can write. This is what beta ji mass per unit what Sir, is there a particle of mass m at point P? Yes, beta. At point P, there is a mass particle, beta. You correct only. Lambda is what, student? Mass per unit length. This is beta. I can say definition of linear mass density. We wish to find mass beta. So what we can do, cross multiply. Lambda into length. Length is what? I have taken beta element. Yeah. So you can say what this is dx only. So now beta, you got dm value. So beta, you can write. This is step one for the questions. Now step two beta g. You have to apply formula for point mass. This is what df is equals to g m1 m2 by what you can see r square here. So student df what beta party g m1 beta what this is beta. You can take any of the m1 here. Let us suppose this is m beta g m into dm. But I know what is r separation between the mass. So this mass and this mass separation is what x beta g only. So you can write my dear this is the x only beta. So df is equals to g m beta. Dm we already found here. That I can just put the value over here. This is dx upon x square. Dx upon beta. Now I can see this expression for single element, but we wish to find what is f net at point P due to rod beta. F net at point P due to rod beta g. Right. So this is beta dx upon x square. We remember this is the integration I'll use more than 10 times in this chapter beta. In this chapter, the student, right? So this is what my dear. I'm telling you here once formula of integration x to the power n into dx beta. What we can say? This is what? X to the power n plus 1 upon n plus 1 plus c. For you can say beta for indefinite, for indefinite. But this is definite here. Beta, just also understand how can you put the limit. So this is your initial point. So what beta? This is also mentioned here. I can say rod to point m distance is a only beta. So you can say this is A beta Z, and this is you can say A plus L, right? Limit beta Z. This is mass beta, you can say initially zero, finally aperture. So you will get this integrate beta. This is what becomes DF. This is what beta, you can see beta F only beta. G M into lambda beta. Oh. So what is integration with party? You can just do like this. X to the power minus 2 into this. First time student, I'll just do it. Next time I'll use forward. Straightforward beta. This is what you can say x to the power minus 2 plus 1 beta g minus 2 plus 1 plus c here. So you can say that this is nothing but minus 1 by x plus c. See why I'm adding? Because it's a, I didn't show limit over here beta. So gm lambda beta what you can see this is minus 1 by x. Limit is from a to a plus l. Just beta put the limit here. I hope all of you know how can you put the limit. Just replace first time variable from upper limit, next beta variable from lower limit. So this is beta g m lambda into beta. Just tell me everyone upper limit beta. Upper limit 1 upon a plus l minus beta g lower limit. Just beta do multiply minus beta inside. Then beta or you can say minus you can take common both things you can say like that. Gm into beta lambda into what it students you can say 1 upon a 1 upon a minus beta g 1 upon a plus l. So this is supposed to write beta g answer of this question. If they didn't mention lambda, then you can replace this lambda. Students, if they didn't mention, I can say beta lambda, then you can replace this lambda is what? M upon L. Just go through beta options, what options mentioned in terms of lambda or in terms of mass and L vector g. Now beta, have a look next question beta. Take snapshot. Everyone. Okay, now beta. So what is next question, student? These all are good questions. These all are students highly important and very standard questions. Multiple time beta, J asked this question, student. Multiple time beta, I can see J asked this question beta, right? Then bacha party, what I can say, bacha, this is students semicircle. This is what my dear, it's a semicircle. It's a student center point O. This is R. At center point O student, there is M mass body placed. No, beta for I said rod and ring. You can take lambda kilogram per meter. Lambda kilogram per meter. So already I said what is the I can say first step to do this question rod. We have a rod means you have to find force at point P due to rod. We have to move x and take element dx right here. Here, what is the thing beta for ring here? This is different approach. You have to move theta. Student, you have to move theta and take element d theta. Student, you have to move theta and take element d theta. Highly required here. Highly required, my dear. Stay in the meeting here. Stay in the live stream beta. You will get everything. Here is the finish point. I'm trying to give you maximum content. You can do notes. That is more than sufficient. That is more than sufficient, my dear. Okay, so beta, this is what gravitational force always attractive in nature. So you can just tell me, beta, what is arc length here? What is this arc length? Simple here, r into d theta. R into beta what? It's simple you can apply bacha. Students simple you can apply theta is what arc length of one radius bacha bati. So what you can say R into theta. Simple bacha as usual. Now students I can say for this condition beta, what is the things? Just for more clarification here, I wanted to just more diagram. What question here? Find F net. Find. I already explained the question bacha, but I forget. Find F net. Mass placed at mass placed at center of semicircle, right beta? Just this is a question, my dear. The students here, just go through everyone here. What I can say, beta, everyone know this is the direction of gravitational force. So student, I'm calling this is df because I have taken element, my dear. So this is what I'm calling df. Now student, this is what I can say theta, right? Then you know beta, force belongs to quantity vector. My dear, force belongs to quantity vector. So student, you can write, you can take again beta component. This is what, my dear, df cos theta. And this is beta g df sin theta. Simple beta. This force beta, you can say, I'll calculate here only beta. This is fx, this is fy. Right. So students, fx, student fx, you can write, this is what, my dear? df cos theta. And fy beta, you can write df sin theta. Before proceed to this calculation beta, first we have to find what is the df. What is the df? So, student, here I'm finding here df values. So, student, I can write df is what? G m into beta. This is dm. Beta, this is m. Radius remains fixed beta. So, you can say this is r square. What is dm here? What is dm, bacha? DM force beta, what I can write here? Lambda into R d theta. As I said previously also bacha. Lambda into R d theta beta. So this is finally beta. You can write. I'll write here. Don't be jumble. So this is beta. I can say DF force is what beta? G M lambda R d theta upon beta R square. R are cancel here. So you can write, student, for df value, this is g m lambda into d theta upon beta what I can say r square, upon beta what I can say r square, right? This here beta, this df value which I calculated, I'll use straightforward. Student, I can say this is what fx. So this is g m lambda upon beta g r square cos theta d theta beta. Simple, yeah, as usual. Now, students, you can say for this condition, beta, no, this is just integrate here, both sides. So, students, fx beta g, this is g m lambda by r square. Now, student, what is the integration limit here? You know what's beta for semicircle? What is the limit beta? What is the angle for semicircle? Pi only. So limit you can apply beta g 0 to pi. This is beta. I can say cos theta. This is beta cos theta d theta. I'm just giving you beta formula here. Those candidate who is newly who don't know about integration beta, right? So integration of cos theta formula beta. Integration of cos theta d theta. What you can write? Minus of sine theta. Beta what I can see here? This is reverse beta. My bad. It's the plus sine theta bacha. It's the plus sine theta bacha. Okay. So students, fx you can say gm lambda upon r square. Beta this is sine theta. Limit 0 to pi. Student, I hope all of you remember sine n pi is equals to 0. Whatever pi value, pi, 1 pi, 2 pi, 3 pi, 4 pi, whatever. So beta, you can see everywhere sine pi remains 0. So beta, fx, you can write g m lambda by what? R square. Fx beta what? You can see g m lambda by R square. This is, no, wrong answer. Fx is 0. Fx is 0. Why 0? Because sine is 0 bacha. Fx 0 better is. Now yeah, student, just pay attention to calculate f by. So f by bacha, this is f by d of beta we already calculated. G m lambda by beta what? I can say r only near. This is r only beta everywhere. G m lambda by r bacha. Integration of beta, this is sine theta d theta. Limit 0 to pi beta as usual. It's a semicircle. Now, bacha ji, you can say beta for f by g m lambda upon r. Student, I'm just telling formula. Those who is new in integration, who don't know beta, sine theta d theta. This is beta. You can say cos. It's a reverse beta formula for accuracy integration differentiation, my dear. So this is what I can say. This is beta is sine theta what? Minus cos theta beta. 0 to pi. 0 to pi. Students simply can apply the limit. Students simply can apply the limit beta. Simply beta apply the limit. Right. Okay. So beta fy you in the beta says further calculate g m lambda upon r beta minus you can keep it out here upper limit. So this is cos pi beta minus upper limit minus beta g lower limit. Upper limit beta what I can say lower limit. Now bacha ji fy beta what I can say bacha this is g m lambda by r beta cos pi minus 1 cos 0 beta 1 only here. So you can see this is what? Minus 2 beta. Minus 1 outside beta also. So Fy is what beta? 2gm lambda by r. Highly important beta g, which I got. So this is Fs beta. What is the F net here? So F net is supposed to write at central mass beta. This is 0 only here. So this is Fx plus beta Fi, which is equals to 2gm lambda by r. This is F net beta, which you got here, right? So it's a beta highly and very good numerical. Very good beta ji. Okay, someone responded. Got it. Very good beta. God bless you, beta. God bless you, beta ji. No, just stay at this point. It's a tough numerical beta. Truly, I'm telling you. Student, it's a tough numerical, but I can say you got it. You got it here. Student, just you can write here in the chat box. Are you enjoying the class? Everyone, write in chat box, student. Are you enjoying the class? Yes or no, student, you can write here. Now, beta, let's move next questions here. Students, these all are good question, beta. These all literally very good question, student. What's the question, student? You can say there is a mass particle, right? This M mass particle, student, got divided in two parts. What beta? I can say this is M. So remaining, you can say capital M minus small m. Capital M minus small m beta. Right. So student, after this is statement questions here. I don't want to waste your time. I don't have also time much to just dictate the questions and write the question. There is a mass particle which is divided in two parts, M and small m. They placed at a finite distance or finite separation. This is m beta, and next one you can see this is m minus m. Both are student, you can say, placed at what beta? At a finite distance. Beta, what question the mention here? I can say both are beta, I can say balanced due to what? Gravitational force. What bacha? Both are balanced due to what beta I can say? Gravitational force. Beta I can say mass. Then bacha, find the ratio of what beta questions I can write last line here. Find ratio of beta small m upon capital M if gravitational force. What beta? If gravitational force is maximum. Is what beta I can say maximum. That is the point, Bachar Party. It's highly required. I'll repeat question once again here. I didn't get any, I can say, response from your side, anyone. All of you join the class. All questions, are you getting clear solution? Student, just motivate me, yeah. Your comment motivate me a lot, beta. Right. So what's that? This is capital M by party. Very helpful, sir. Okay, student. God bless you. Now, beta, capital M. Now, this is divided M and M by sir. Both are placed at a finite separation. Find the ratio of M upon M if gravitational force is maximum. That's all. This is the question, student. Now, student, have a look of the question solution here. First, you can write beta expression of force. First, you can write beta expression of force beta. So F is what beta? You can say F is equals to formula I'll use beta. Simple. F is what? You can say G M1 M2 by what? R square. So M1 beta, I'll take M here. So I can say F is equals to G. This is small m beta. I'll just write differently so that you can understand beta. This is R square. You can just open the bracket beta. So what you can say F is equals to G beta G small m capital M upon beta G R square minus student G M square by beta G R square. Now student, I'm going to use here some principle of maxima minima. So now I'm going to use here some principle of maxima and minima beta. Okay, so student, for maxima, for a student maxima, what I can say, differentiate any function and is equals to what? Equate to 0 will be the answer. Differentiate any function beta, differentiate student any function and equate is equals to 0 will get answer the student. Right, my dear? Okay, so this is beta F, you can feed over there, bacha. This is F, bacha ji. This is G small m. Okay, student, God bless you. This is G small m beta capital M beta upon what you can say R square. Beta, what is variable here? Mass. Small m is variable. Minus the property. This is differentiation of G. This is m square. Oh, God bless you, student. God bless you. G m square upon beta R square into dm. Student, if you are getting the class here, everyone be respond. Now, bacha, you can say further beta. This is you can take beta. G and capital M by R so common. G student capital M by R square is one common. This is simply you can say D of M upon beta G. This is dm minus beta. Again, you can take common here. G upon R square beta. This is differentiation of dm square upon beta G dm here. Now, students, you can see dx by x. I hope all of you remember. Otherwise, I'm writing beta dx by dx is what beta 1 here. So, student, you can see dm of beta dm, which is equals to member property. So, dm square by dm beta, this is what 2m. Student, I'll apply simply formula here. Differentiation of x to the power n upon dx. Beta, what I can say? What I can say, my dear? This is you can write n into x to the power n minus 1 beta. That's all. Very simple here. At physics point, you will learn physics easily, student. This is G capital M beta. This is R square minus G small 2m upon which is the R square. right? Beta what? You can see is equals to 0. So just equate here. What we will get? G capital M by R squared is equals to beta G into 2M by beta G R square. You can see here G by R square, G by R square, cancel here. So finally, beta, you can write your answer. That is what, my dear? That is what, my dear? This is capital M is equals to 2M. We wish to find what, beta? Small m upon capital M. So you can say, beta, small m upon a capital M, which is equals to 1 by 2, which is equals to 1 by 2. So student, this is answer for this question here. Student, this is answer for this question, my dear. Right? Okay, have a look next question here. Because no, maybe session will long, but student, I don't have a choice because I have a time is rarely I'm getting. So today I'll finish gravitational force, beta, next gravitational field and all. Now, Bachaji, I can say next question here. It's been again highly important. Highly important, beta. So, what's the question, student? This is, let us suppose this is the square. I can say beta triangle. This is what is been triangle. Now, students, this is the circle. This is what circle. This question has been asked by Zay multiple times, which I explained these all questions asked by Zay multiple time beta. Okay, so now beta here I'm placing this is mass identical everywhere. This is M and M. This is a question beta. Now this body is when I'm going to place. I can see what on the periphery of a circle. What my dear, this triangle I'm going to place on the what periphery of a circle. Then find speed at any corner. Student, what is find? Uh, Jitra, God bless Bacha. Speed at find speed at any corner. At beta, find speed at any corner. These all things are mentioned. They are balanced due to what I can say gravitational attraction forces. I can say between particle to particle. So find speed at any corner of the particle. Student, find speed at any corner of the particle. Find speed at any corner of the particle. Find speed at beta what? You can say any corner of the particle. Okay. Now, what's buddy? What I can say. Because this thing I'll not do again because just now I finished there. Yeah, I can say beta for triangle masses, right? So with Chapati, I can say for solution here, we already got. I'll not do again, student. Go and watch this explanation of the questions. M beta, this is remains M only. This is remains M beta, right? So student here, force I can write. This is all of you know root 3 gm square by a square. Now, now beta, it's interesting here. You know, this is what beta every particle. You can take beta everywhere masses is m and v is beta speed of particle. Under these forces, what I can say, radial forces beta. That is what you can see gravitational force only. Now, students, particle revolving on a periphery of a circle. So, student, here you must find what is the radius of the particle. What is student? What is the radius of the particle? Simple beta. Okay, right. So beta, this is radius. How can we get here? Easily can find a student. Listen here. Bacha, this is center point O. I hope all of you remember. This is what? An equilateral triangle. This is what beta I can say equilateral triangle. So what's the angle entire beta? 60 degree. So this angle is what I'm considering over here. This is what 30 degree. This is what my dear 30 degree. Okay, I'll make here this diagram over here only for triangle to find radius for more clarification. This is O beta. This angle I said. This is what is student 30 degree. Right. Now students I can say draw perpendicular from here to here. Then what's the length entire beta? A. So this is what you can take beta A by 2. Since I'm calling OA beta. Now, so just I'll take student component of this OA. So what beta? You can say OA cos 30. Student, you can say literally, yeah, it's a highly important. OA cos 30 is equals to beta A by 2. Then you will get OA. And OA is nothing but it's a radius. It's a what? Radius of particle moving on a periphery of a circle. So now students, you can write over here OA cos 30 degree, which is equals to A by 2. So OA beta cos 30 is what? Root 3 by 2 is equals to A by 2. 2 to cancel here. Then student OA you can write this is A by root 3. This is what my dear OA is equals to A by root 3. Simple. Now bacha body. This is nothing but you can say it's a basically radius. It's a basically radius. So just know because these two are what? I can say balanced motion each other due to gravitational force. So I'll make your ABD at this point. Let us suppose beta this point is what already I said A. So at A, now beta here I'm going to use concept of circular motion. Now students I'm going to use over here what concept of circular motion. Now beta what you can say for this condition gravitational force beta. Just go in step here. So this is step one beta to find radius. This is what my dear to find radius here. That is a diagram for this one. Okay. Now, beta, this is the diagram for radius. This is students, I can say step three. Now, students, step four here. That is the last part for understanding of this question, beta. No, beta, this is FG. This is what direction of FG, my dear. This is what direction of FG. Now, students, this is the direction of FG here. Now, you can say, beta, this is what basically FC. FC is what it implies. This is a centrifugal force. Okay, Arav. Arav, beta. You welcome, beta. Once again. Then, beta, Arav, literally lucky. These all are good questions which I'm solving now, beta. Arav, basically, from where are you? Arav, basically, from where are you? FC, beta. Centri. This is beta. Centrifugal force. Centrifugal force beta. If any particle which is revolving on a beta, what you can say? Circle. So according to circular motion concept, you can say what centrifugal force always acting away from the center. Students, here you can equate these two. Fg is equals to what, my dear? Fc. So student, you can write over here. Oh, daily. Oh, very good, Arabita. Very good, my dear. Fg is equals to what beta? Fc beta. Fg beta we already got here. This root 3 m square by a square beta. You can write root 3. What beta is he? Root 3 beta. But I'm in living. Huh? Yes, very fine. Very fine. Arav, you tell honestly, yeah. Are you getting my class beta? Because when you join beta, this I can see this point YouTube channel. Today or before that beta? Arav, when you join beta? Today only. Are literally to see you are, I can say, very happy. You are literally a candidate. You are showing your parenting beta. Literally, you are very good beta. Ji. GMS square upon what beta? I can say A square beta. This already calculated Arabic. FC Arabita, all of you know here. What is FC? Centrifugal force beta. This is mv square by r. A particle has a moving with linear velocity r. Or you can also say Arabic. Fc is what beta? M omega square r. If a particle is rotating beta, right? So here student, I'll use this formula beta. This is my dear mv square. And r we found beta. A by root 3. Okay, Arab. Very good beta. Very good Arab. No, literally student Arab, I can say, I also newly started here, I think live classes. Some student requested me. Yes, Arab, then you will get benefit here. Arab in which class you are? 11th or 12th? Arab in which class you are? 11th or 12th? Beta, can say this root 3 cancel with you. This A cancel with you. Okay, you welcome. Now bacha, I can say V beta we can write here. This M cancel bacha party. So step 5 beta. Finally you can write what's answer of the questions. This is what beta? V is equals to root of GM upon A. This is what beta root of gm upon a. If you literally join the class, everyone, 11th Arab, very good. Which topic going, students, in your, I can say class where you are going for tuitions or beta classes? Which topic beta currently going into beta, going there beta? Okay, Arab. Okay. Now bacha, I can say, beta ji, here, just do next questions here. Student, everyone do next question. Arab, is this clear? Just tell me, student, Arab. Arab beta, is this clear beta ji? If yes beta, then do next question here for your self practice. Because you joined newly beta ji. You joined newly beta ji. Okay. So what is next question? Student, next question. Student, take snapshot. Right. Now, bacha ji, have a look here. Next question. Now, students, this is beta ji. This is square. Same questions which I have done previously. Beta, this question already asked by J, right? Beta, this is unequilateral triangle. This is a student unequilateral triangle. Masses remains m. This is masses remains m beta. Okay. Now this is the beta. I can see this is already done here. This is the next question beta. I can see there is a square. Already I have done it. Sir, do you have children? Do study beta Arab. Bacha, I can say yes beta. Arab beta, this is square. This is square, my dear. Side A. Everywhere is when I'm placing mass identical M only beta. This is M bacha party. Right, my dear. This is side of the square beta. This is A. Right. So now I'm going to place this entire beta, I can say square on a periphery of circle. On a what beta? Periphery of circle. Questions remain same. Find speed at any corner. Students, questions remain same. Find speed at any corner. Beta mass is m here and all are moving with velocity v bacha. So students here find speed at any corner. What's the question, student? Find speed at any corner. Same question, bacha. So student, wo I can say solution here. Step by step, beta. This is the lengthy questions I can say. So, beta, this question already I calculated here. So, I'll not calculate again. What is the force? What is the force, my dear? Right. So, this is students, I can say, beta, this is mass m square beta. This is mass m beta. Newly, just I calculated here previously, bacha, not newly, previously. What is F net beta G? I hope all of you remember. Otherwise, I'm writing G ms square by beta G a square 1 till beta 1 plus 1 by root 2. I can say this is root 2 plus now beta. This is root 2 plus 1 by 2. This is root 2 plus 1 by 2 beta. This we already got here. Now, students, again we have a challenge to find what? Students, I can say yes, Arab beta. Very good. Arab, Arab, spread me here among your family, friends, so that student maximum can get benefit student from physics point. Now, beta, this angle is what? 45. So I'll make this diagram over here only so that you can easily understand how to find beta. Radius here, I can say this is the main things for this question, my dear. Right. So, beta, this is a center point O. Student, this is 45. I hope all of you know that do we have an app? No, student, I don't have app, but I'll student everything I'll do very soon, right? Beta, I'll because I'll teach live beta for few months. Then students are I'll make a proper setup of everything beta like app, module, textbook, everything. I'll avail bacha. Just give me some time bacha. That's why I'm doing more questions over here because these are the questions literally highly important bacha. So this angle beta what are? Tell beta, this is what? 45 degree. This is what, Ara beta? This is 45, my dear. Every student, I'm addressing everyone. This is student, I can say A. So this is what beta? A by 2, right? Simply beta. Sir, you teach in physics point. No beta. I have, this is my own personal institution, Ara beta, right? So now currently I'm teaching at beta here. So here I'm doing job student, Arab. Arab beta, here I'm doing job beta, right? Now, bacha, it's my own form beta, physics point. Now, bacha, Arab, beta, this is OA, beta. We wish to find radius here. You can take beta again component. This is what? OA cos 45, which is equal to beta A by 2. Arab, you got beta, which you ask the queries. OA beta is cos 45 degree is equal to beta A by 2. So cos 45 beta, what we can see? 1 by root 2 only beta. So this is what? OA. The advanced 2022 was from there, it came in news. Did you teach him? Yes, beta. No, 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 no. The advanced no, beta. Arav, I can tell you, beta. Student already I produced 100 percentile student, classroom students only. 100 percentile beta, my one kit already produced, my dear. That is 2024 in physics beta. Only in physics. Beta, only in physics, right? This time I was in a class. This time beta. So 100% beta, my one classroom kid produced in 2024. Finally beta, I can see he got a call from IIT Roorkee. IIT beta, this is Roorkee. Beta, this is electronic communication engineering. Electronic communication engineering, Arabic. Okay, Arab beta, just have look beta here concentrate Arab. Such children got that rank. Yes, sir. Children beta, I can say beta he got rank in advance 3202 beta. Yes, this is AIR Arab beta in advance. This is beta I can say JE mean. I told beta this is JE mean percentile bacha. Student I told Arab bacha this is JE mean percentile bacha. In rank in the advanced beta 3202 or 303 beta like that beta approximately. Yeah. So, student, Arab, I hope you got what you wanted. No, 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 no. Classroom like you, student, student like you are also you are now just connected at physics point. So you are also a part of I can say physics point. So just I told about the classroom student. Listen carefully. Classroom student got the this rank here, right? OA beta cos 45. What was that? This is 1 by root 2. Which is what beta? So they can write beta. OA beta what you can say? Root 2 into A by 2 beta. Just multiply divide by root 2 beta. Then beta I can say cancel here. So what you will get radius beta party? Students radius you will get OA is what beta? A by root 2. This is what my dear A by root 2. Simple here. No, these all bodies what? Moving each other due to gravitational force bacha. So you can say this is what? Students basically FG and this is what beta FC. This equate bacha part. FG we already got here. This is G M square by A square root 2 plus 1 by 2 is equals to my dear M and V is what beta? We wish to find it MV square by R. R we found beta R over here only beta. Student R we found here bacha. This is A by root 2 bacha. So you can say this is A and this is root 2 bacha ji. So masses beta cancel. A is cancel. Right beta. So what we can write here for V? V is equals to beta. You can say this is GM into oh Arab. Got it. Okay. Root 2 plus beta 1 by 2. Upon bacha ji, what I can say? This is what root 2a. So beta, I can say this is answer for this question here. This is answer. Student, it's a highly important and very good questions. Very good question, students. So I can say this is all about pattern of force here, which I already completed. But still, I have a few questions. Still, I have a few questions, beta ji. Take snapshot, beta. Everyone, take snapshot here. Say, just revise your notes, beta. Revise your notes, beta ji. Now, student, this is a question asking JR 2026. What 2026, beta? I can say previously I also was doing the same question. Now, student, what's the question, beta? I can say there is a this is a homework question, Ara beta. I'm just giving you a few homework question, beta. Everyone do and just revert at b.sharma9219 at the rate of gmail.com, beta. For meanwhile, I'll give you very soon. Please find like say Telegram channel. There you can send your assignment solution. This is beta. I'm just calling. Let us suppose this is M. This is 2M. This is 3M. This is 4M beta. This is 2026 means already asked, but I can see this. Previously, they also asked. Square side beta, you can take A. What you need to find? Let us suppose this situation beta. In this situations, you are getting F1. Right? This is case 1 beta for this question. What is case 2, my dear? Same question beta ji. What say? Beta in the question, they interchanged. They interchange what? I can say 4M to 3M. So just beta, this just interchange the position. Student, you can say this is interchange the beta position. This is amateur, this is remains same, there is no change. Now this is the 4M and this is 3M beta. Here, let us suppose this is what F2 you are getting. Then find a ratio of what beta ji? F1 by F2. Student, find ratio of what? F1 by F2. But let's find ratio of F1 by F2. Okay. There is one more bit I can say homework questions which is asked by J. Right. I can say for different masses which are, or you can take same masses here. Okay, beta, this again homework questions. You can see in your solution b.sarma9219 at the rate of gmail.com. Yes, beta. This is beta. I can take this is mass m. This is mass m. This is mass m. This is mass m. I can say you can take beta. This is m. This is 2m. This is 3m. This is 4m. Same question beta. Let us suppose, students, there is one more mass I'm placing beta over here. Student, there is one more mass beta I'm placing over here. At what? Center of I can say square. This is what, my dear? This is square side A. This is what, my dear? Square side A, right, beta? So I can say, bacha, this is. You need to find, beta, you can find over here. What, bacha? Find the gravitational force F net at M. Find. This question also asked in JR. Just now I remember. Yes, beta. Find F net at central mass. What beta? Find F net at central mass. So, student, I can see these two questions for your homework are do and beta just send me solution b.sarma9219 at the rate of gmail.com. Right, beta ji? Okay. So I can say, students, there is one more question here which I wanted to do. Now, students, have a look at these questions. So, what's the question, beta? What is the question they asked already? Hmm. Yes, beta. I can say two particles, equal masses, move in a circle, right? Under the what, students? There are two particles. They are moving, students. Again, here it's a standard question, which I'm doing here, which literally it's a standard question, which there are two particles, beta. Anywhere you can take, either here, here, here. I'm considering which this is the position. This is M particle. This is what, beta? M particle. Beta, what question? Two particles equal masses. Equal masses move in a circle of radius r. Students, you can take what is the radius of circle? This is r. Move in a what? Circle of radius r, which right? Under the what? Action of mutual gravitational attraction force. Find the speed of each particle. If mass of each particle is m beta, mass already given here. Same question here, which I've done previously two questions. Find speed of particle. Find beta. This is speed of particle. This question asked by student in like CJ. Maybe I'm forgetting your year, but I'm pretty confident. Already asked this question beta in JE. So what's beta things here? Again, no, it mention the question. They are what moving due to what attraction of gravitational forces. So you can write with there. This is Fg due to this body in the direction. This Fg direction, my dear, in this direction. This is what, my dear, Fg in this direction. So we have to find the speed of particle. Speed of particle beta. So what we can do? Simple, yeah. It's literally pretty easy question. Pretty easy, students. I can say this question. Gravitation comes circular motion. That's all. Now, which I can say this is what direction of beta. You can write Fg. Now, previously I said. Again, I'm repeating. Student, this is Fc. Fc is what centrifugal force. If any particle which is moving on a circular path, then with a centrifugal force always acting on the particle away from the center beta. This is what Fc. So here you can equate. This is I can say step one, which I made this ABD. Step two beta, this I'll equate magnitude of these two forces. Fg is equals to Fc. What is FGR? I'll write individually. Fg beta, this is G, M1, M2 beta remains same only. GM. Don't take beta separation as R. No, it's a wrong beta. It's a wrong perception, student. It's a wrong perception, student. It's a student wrong perceptions keep in your mind. It's a highly beta. It's not good here. It's not good beta ji, right? It's not good beta ji. Beta, what separation? 2R you can take beta. This is what, my dear? 2R whole square. So Fg beta you can write G m square by beta 4R square. Fg beta you can write what? Gm square by beta what? You can say 4R square. Fc beta, already I said, this is mv square by r. And r beta here remains same r only r. Means you can say beta like that. Sir, r is equals to r. R is equals to r beta. Let's equate beta. Already we got this 2 beta, magnitude of the force, Fg and Fc beta. Simply you can equate, my dear. Gm square by beta is 4r square is equals to beta. This is mv square by r. R cancel beta. Mass cancel here. So we will get this is Gm by 4r. Now you can answer of these questions. Now, beta, I can answer of this question here. There are many questions which I'll send you, beta, very soon on Telegram. Oh, very good afternoon, my dear. How are you? I can say session going to finish, beta. I finished gravitational force. This is around 2 hours, beta. I was taking classes, right? Still, I'm taking classes only. So I finished in this lecture as well, gravitational force. Gravitational force student. I can say if you want, just go and watch the entire lecture student. Literally, you will get benefit. You will get some questions, new approach to solve the question further students. So this is the student I can say all about for this lecture, right? Remaining beta I'll just do in next lecture. Very soon I'll plan your lecture. I'll do over there. I can say that is what, my dear, gravitational field. But before that, yeah, I wanted to do one question because just looking, sorry, I'll do one question. Yeah, that is last question for today class. Sorry, beta. What's the question? Beta, I can say there what? Two, beta, two particle, two mean orbital radius. I can say beta Earth. Radius beta, I can say mass of the sun. Leave it here. This question. Yes, beta. You can do this thing, beta. You can do that. Beta, what I can say. This thing new beta questions. Sure, beta. Just you can say yes or no, beta. If you have done this question, I can say at your institute student, then you can say yes. Otherwise, say no, beta party. Listen, beta. This question. First, beta. This is M beta party. This is remains M. This is remains M star. Right? Okay. Beta. This is unequilateral triangle. First part, beta. Sir, already I completed. But again, I'll repeat. Now I'm going to place this equilateral triangle, sorry, on what? Periphery of a circle. Find the following beta. Find the following. Find following here. So what is first beta? Speed of particle at any corner. Speed of particle at any corner beta. Now in second beta, find time period. Find time period of revolution. Okay, sorry. Sorry, did you already have done this question at your institute? These two part or one part only? Sir, you are also from Rajasthan, and one boy is joining today, Arab also from Rajasthan only. Means, oh, very good, very good, very good, very good. Can you write answer bit of these two part in chat box? Sorry. Okay, so student, I'll go here for solution of the question. I'm solving it. Sorry, just you can answer me these two part, student. Okay, yes, right, beta. So this is an equilateral triangle, beta ji. So what is the force? So I'll use a straightforward result here. This is M, this is M beta, this is M beta. So what is force over here? This is root 3 gm square beta g a square. Now, so this is step one for the questions. In the step two beta, now this triangle I'm placing here according to questions on the periphery of a circle. This is mass m beta. This is mass m beta only. Mass m only beta. Already I said this is what? Radius of the circle. Newly just I found beta. R is what? A by root 3. Yes, R beta. Very good. R is what beta? A by root 3. Then beta, what is speed of particle here? Simply I'll say till now beta, sir, I didn't get answer from your side in chat box. FC beta. So FG beta, you can write this formula beta. FG we already got. Root 3g. Here, Arav, I didn't teach more, didn't explain more, bacha, because these all things I explained previously, bacha. G m square by a square. And this is what, my dear? Mv square by beta what? A root 3. Root 3 cancel beta, Arav. A cancel beta, cancel beta. So, tomorrow, which chapter, sir? Tomorrow, students, Arav, I'll just finish beta. I'll finish all 11th class chapter from here onwards. Beta gravitation, then fluid, then beta all chapters I'll do. Sir, I don't have a notebook currently. I'm calculating my mind. Okay, very good. Super beta, very good. This is beta V is equals to G M by A. Sir, beta, is this right? This is beta, G M by A beta. You did Arabic, sir? Already I solved beta previously also. Is this right, Arabic, sir? Okay, good, beta. Sorry. Now, beta, this is step one here. This is step two, beta. Step three here. And now I'm going to calculate time period. Oh, good, Arabic, sir. Very good, beta, for your reply here. God bless you, beta. So this is, you can say, beta, the time period. This is what my dear time period. So, can you tell me, sir, sorry, Arab, what is the beta time period? Just I'm just calling every student who I can say part of I can say this live session. Those already joined here. Thank you so much for your interest staying here. 2 pi by omega. 2 pi by omega. You can say. Beta omega here, or we can use beta. Sorry, this formula here. 2 pi r by v. Simple omega you can write on d by r beta. No, sorry beta. Omega what? We can say d by r beta. Good beta. Good sorry beta. Now beta time period beta. This is what 2 pi beta and r beta what? A by root 3. Yes sir. Both are. Yes. Very good beta. Sir, I'll start very soon here. Beta, I can say advanced practice numerical. That is a question. That is a session only for design advanced candidate beta. This is I can say beta again. This is a request by the student, so that I started. So I'll start finish the chapter also, bacha. I'll start one advanced session. only problem session. And one beta, I can say, I'll start tablet course as well. Those students will go to write JEE means in April and advance like in May or June beta advance. So we beta, what we got? This is root 3, root 3 beta. Sorry, this is V bacha G M by beta. This is you can say root A. So finally, you can write beta 2 pi a to the power 3 by 2 upon bacha root 3 gm. You can say beta indirectly you got result of what k plus law third. Now beta, sure, this is what k plus law because no, this entire terms is constant. This entire terms is constant. So you can also write here square of time period. But I can say during explanation of Kepler's law, we used what beta? We will use what beta I can say? That is what? Concept of an elliptical path. But this is what proved, I can say. What this is circular path. So these two are not same, but I can say result almost, but I will get same here. Square of time period is what? Directly, but what I can say this is the AQ. Yes, Orbita. Yes, Orbita. This question I remember got to see you, Vacha, right? Otherwise, I forget, Vita. Sorry, this question. Right. It's a standard question here. So, this is all about student. I can say today class. God bless you all the very best. Stay connected at Physics 1. Physics 1 is a prime suit to help each and everyone according to your expectation, student. All the best, everyone. Now I'm going to just stop this live session. I'll again connect in the night if possible, Bacha.